Alright, hello and welcome to the next week of lectures. This is only going to be a one lecture week because we have Thanksgiving on Thursday, and I'm pretending that this is a Tuesday-Thursday class, right? So we're going to have just one lecture this week, and it's going to be about the world beyond C++. So let's get started, and I just want to not warn you, don't worry too much. Maybe I'll test you on some very, very simple programs in these languages, and then you can just go and run them if you needed to during the final. But I'm not going to test you on like the fancy libraries that I'm about to talk about. So I'm just going to try and get as much Java and Python into you as possible today. I'm going to focus on the Java though, just in case you transfer to a school and it requires you to have learned one of these languages. I think C++ is probably the most common thing to teach, and then it's Java, and then sometimes there are intro classes in Python, so I'll give you a little bit of that too. Okay, so let's get started. Java, in fact, you kind of already know it, because same with Python, in fact. They're all object-oriented languages, and so once you learn one, you kind of know them all, which is really nice. And do take advantage of this fancy website, this learnxandYminutes.com. It gives you a short tutorial about any language that you might be interested in. So that is my spiel. Let us start with Java, and I guess the key takeaway for Java is that everything is a class, okay? So let's get started with the hello world example, of course, with a comma and an exclamation point. And let me make for you a file called helloworld.java. All right, so this needs to be larger, excuse me. And let's see if I'm in the right place. No. There we go. Okay. So, we're ready. I'm going to make a file called helloworld.java. .java is the extension for Java programs. And let's get started. So I'm going to say public class hello, and then I'll give a main function, and I'm going to say system.out.println hello, comma, world, exclamation point, semicolon. Okay, so that is almost helloworld.java. I'm going to explain all these things after we get this working. So once we have a working Java file, we can use the Java compiler, which is called javac on your computer, to go and compile that. Okay? So let's try to compile this. javac hello hello world.java, and we're going to get an error. Class hello is public, should be declared in a file named hello.java, and this is the first time we see this error. So in Java, in each Java file, there's supposed to be a public class. That's a class that's visible to everybody. It's public. And that class has to be the same name as the file. Without the extension, of course. So if I want this to actually compile, I have to call this class hello world. Otherwise, it won't work. Otherwise, it should have been in a file called hello.java. Hello world.java now will compile. Okay, so now it's compiled. And again, don't worry, I'm going to tell you about all these things that I'm talking about, all this code. This, when I compile it, it makes something called helloworld.class, which is essentially a compiled form of code. So here we made helloworld.class. That's the compiled form of helloworld.java. And okay, it's not quite the compiled form. It's a special thing that I'll talk about later. And we can run that now with Java, just the command called Java. We say hello world without the .class or anything. That'll run the compiled file. All right, we say Java hello world, and bam, it prints hello world. All right, so let's explain this. Okay, yeah, so this is the hello world class, and that makes this hello world.java file. It's visible to everybody. And here's the main function. Java programs also have main functions, and they have to take the command line arguments. The type of those command line arguments is string array. Usually they call them args. So arrays have a slightly different syntax. So string bracket bracket means string array. And in Java, the string type is capitalized. Okay? And it's automatically included as well. You have to import it up there. And then we get to the one line of the body of the main function. It runs the print line statement. This is system.out.println. System.out lives inside of the java.lang. It's part of the Java language. So it's technically java.lang in full. It's java.lang.system.out. Okay, but java.lang is included for us always. And the print line prints a single string, with a new line at the end of it. You can print other things as well. All right, let's go there. This is a very nice feature of Java. We have documentation all over the place from the Java standard library itself. So you don't have to go to a weird website called c++.com that's not made by the C++ people. No, Java makes their own documentation. That's quite nice. Okay, so java.lang, that is the fundamental classes to Java. And inside of that, there is a system class. And inside of that, there is an out object. And it's of type print stream. So an out is a print stream. So what does print stream do? Well, I think it prints stuff. And it has a method called print line, and one of its overloads takes a string. You can print an int as well. Okay, that is essentially that statement in a nutshell. Okay. This main function is declared static. Main is a static function, which means it belongs to the class itself. C++ does have this as well. Not any of its objects. So it's like it's hello world dot. It's the class's main. It's not like if I make a hello world object and then try to do h.main, that doesn't work. This is a lot to try and throw at you in one lecture, I know, but this is all I'm gonna say about that. So it's a static method, and in Java you have to say what's public as part of the thing. You can also say private, protected, all that stuff. Okay, so that's essentially the hello world file. Hopefully it's making a little bit of sense, and let's move on. Okay, so there is a lot to go over. So Java runs on what's known as a virtual machine. So it's we compile programs, and we can actually go and run those .class files on any computer, which is not the same as C++. When we compile a C++ program, that program is specific to like an operating system. Like it can only run on Windows computers with an Intel type CPU. Okay, that is a very different thing to Java, because everything will get it's like partially compiled in a sense, and it runs on the Java virtual machine, which like brings it down to the CPU level whenever you run it. Okay, everything is also a class, so you've noticed that with the if you just want to write a main function, you have to write a class. Everything's inside of a class somehow, and let's talk about these things in a little bit. All right. I don't know, examples .java, or let's just keep it part of hello world. Why not? So I can say normal stuff like the ints exist in Java, int I equals 0, like print line I That's totally fine. Like I++ is a thing. These are all normal things that exist. Like we print 1 now. Okay. Anything you ever want to make, though, that is not a primitive type has to be made on the heap. You have to use new, and that includes arrays. So here's an int array. Brackets go by the int now. Equals. It's not just 1, 2, 3 anymore. You have to say new int array, and then you can give the values. Okay? So that's what the array looks like, and then I can go and loop through it, of course, for int I equals 0, I is less than ARR dot. Actually, arrays in Java know their length. Okay? That's super nice. Then we can just be like, I don't know, we can print it out. Print out that index. Okay. Let's see here. Oh, sorry, I already defined variable I, so I can't do this again. I have to say j. Oops. There we go. And I'll go and print that 1, 2, 3. But this array got made on the heap. Everything gets made on the heap. You have to say new all over the place for non-primitive types. Okay? Though you have to say new all the time, you never have to say delete in Java. Java is what's known as garbage collected. So it's going to call delete for you. There is no delete in the language. It just does it for you. It notices when you stopped using something, and then it just gets rid of it for you. Okay? Which is super nice. That is Java in a nutshell. Everything's a class. There are no pointers. Everything is like a reference. And we'll get into that in a little bit. It looks a bit different than the references from C++, so you don't ever have to say star or anything. And we'll get to that when I show you this counter class. Okay, so this is where I just go to code that I've made already, because we just don't have enough time for me to tell you everything and write it with you. Again, don't worry too much about any of this. This is just for your knowledge in case you transfer somewhere that has Java as a requirement. So here's a counter class, public class counter, and then we can declare all its stuff. So every counter needs the count that it's storing. I'll call that x. And it's a private member variable, and I have to say private next to it. Okay? The constructor looks normal. If you don't give it anything, it's x equals 0. If you give it something, it's x equals that value. Java has no default parameters, so you can't just like make one constructor that looks like that. You have to make 2 if you want those. Then we can give the count back, a getter, an inc function, a reset function. This all makes sense. We're just adding public everywhere. And there is no declaration. The declaration and the definitions all come together. Everything's a method. There are no functions. There are no method declarations. I guess there is a function if it's static. There are no method/function declarations in Java. You just go and implement the thing. So there's no like, okay, I'm going to put a semicolon there and I'll define it later. No, you do it all in one go. Everything's in one file. Okay, and there's no operator overloading. You have to use the word. So like there's no plus operator. You got to say add. Okay. There's also no const parameters. So I can't make this method const, and I also can't make this counter const, which sucks. You have to do some weird tricks if you want to make sure that nothing gets modified, but I don't know, maybe you just have to be a better programmer. Who knows? So this is all essentially the same. It's just there's no operator plus anymore. And all right, then we can have a main function that like tests this out. This is not part of the counter class, so we can make counter objects. They don't all have little main functions in them. This is a static thing. Okay? So here's my main function. If I run this file, compile it and run it, it will make a counter call it C, and I have to say new. I can't make it on the stack. There is no concept of that. And I can increment it 3 times, and what do we think I get? Probably 3. Hey, we get 3. Then I can make another counter, C2. Starting at 42, increment that, we should get 43 back. Hey. And then finally we can use our add operator, but it's not an operator anymore. We have to say, instead of C plus C2, we have to say C.add C2. It's very, very wordy in Java. All right. Then we get the count back from that. Well, that should be 43 plus 3, which is 46. Okay. So that's a counter class. And yeah, I think everything that I want to say is part of this file already. But I can just reiterate things. You have to public/private. You put that next to everything, and there are no default parameters, and there are also there's no operator overloading or const. And these, I mean, these are just features of C++ that made your life easier, but they're not going to kill you. Okay, so some very significant differences between Java and C++ in a nutshell. Thank you, Bill, for this slide. It is not a compiled language. It's an intermediate language. So you compile it a little bit of the way, not all the way to begin with. So then you go and run it on a virtual machine somewhere, which makes it like actually run on the CPU finally. And there are const variables, but not methods. Instead of const, you say public static final. Okay? There's no char. Instead, you say byte. And I guess in C++, a char is 1 byte long, so that makes sense. No pointers, only references. So for example, notice, I kind of glossed over this, but here's counter. I say new counter. There's no star anywhere, and I can say c.inc. Okay? You just pretend it's a thing. It's a reference. It just all works. No pointers. There's no operator overloading. If you want to include something from the standard library, you import it. You don't say include or use any namespaces. Implicitly, every class extends object. There's like a base class that all classes come from. Like if you don't have anything, like up at the top of the class hierarchy, everything has object. All comes from that. Like every other potential class in Java comes from object. And it's the default one. So technically I should, just to spell it out, it's like class counter extends object. That's essentially already done for you. And you get some stuff from that I don't have time to talk about. There is, the compiler is a bit nicer to you than C++. And if you leave comments in a special way, it automatically creates documentation, which you can turn into these amazing looking websites that are very helpful for your developers. And yeah, we talked about garbage collection. It just finds when you don't use memory anymore. It just cleans it up for you. And in my opinion, the libraries are much better in Java. They're super, super cool, and I will show you one of them after we get through this linked list class. Okay, so let us make a linked list in Java. Okay, here's what we're going to do. Public class linked list, and we'll give it a main function. So what do we want a linked list to be able to do? If we make a linked list, it should start out empty, right? We should be able to, like, let's just do the pushback operation on it. We should be able to do l.pushback. We'll make it a list of ints, maybe. Like 1, 2, and 3. And then we can say, I don't know, we can iterate through it. How do we want to do this? We could say, I don't know, we'll just put the nodes together. Why not? Linked list.node. We'll put the node class inside the linked list class. N equals L dot first, or yeah, I think that will work. Maybe we can say get first, and while n is not equal to, you just say null in Java. I could definitely do this with the for loop as well. Okay, we can print out L or n's data, and then we could say n equals n dot next. There's no arrows anymore, so this will just iterate through the linked list that we're about to make. Okay, so that's how I want to make it. And so if I want to use nodes, I got to put a class inside of linked list. So I got to say public class node. And so every node will hold a data value and then a public node next. This is how we'll make the node class. It's like a struct in this case. Okay. And okay, let's make the constructor for our linked list. Every linked list should have a first pointer. And that's really a reference in Java. We'll say, okay, private node or linked list.node. We're already in the linked list class, so we just can say it like this, technically. Private node first. Okay, and the constructor should start the linked list off null as empty, so the first will be null. Linked list first equals null. And then we can have a pushback. We could say, or maybe it's easier to do push front actually. Maybe we should do that. We can say get first. That returns a node. Public push. Do I want to do pushback? Why not? And it's going to be void pushback, and then we give it an int value to add along. So, well, if the list is initially empty, we gotta fill it in. We gotta say first equals new node, and then we can say first dot data equals val. And in fact, every pointer by default is set to null, so we technically don't have to do this. First dot next equals null, but it's good practice. Why not? Okay, so that's if it's empty. Otherwise, it's full. We need to find the last node and add to the end of it. Let's see here. Oh, sorry. I'm using this like C++. Linked list L equals new linked list. How dare I? Okay. So let's find the last node. We'll just be like, okay, node n equals. We could also save the last node if we wanted to. But let's just save first for now. Node n equals first while n dot next is unequal to null, advance n. So now n is the last node. So then we'll say n dot next equals, and we'll just make the new node actually. We'll say new node. And if I wanted to be better about this, I could make the node class have a constructor that does all this for me. We can say new node dot data equals val, new node dot next equals null point, just null, sorry. C++ is creeping up on me, of course, so I'm used to it. And then we can say n dot next equals new node. All right, if I didn't do anything silly, this should be okay, I think. So let's try it. And so it's all very familiar. I hope you're getting that feeling. And hey, we get 1, 2, 3, nice. It's all very familiar, but slightly different. Okay? And this main function has nothing to do with the class. It's just, if we run this file, it's going to run this main function. Okay? So that is linked lists in a nutshell. So we noticed a few things, like null is just null. There's no null pointer. That's the first thing. News all over the place. Public and private all over the place. You can put classes inside of classes. That's not a problem. Yeah, that's about it. Everything's very familiar, but slightly different. All right, so now I want to show you something cool. So I want to make a graphics program for you, a GUI, a GUI or GUI, people say. That is called a graphical user interface. C++'s standard library has no GUI functionality. Java's, however, does. That is not super useful. I think I clicked the wrong link, maybe. Aha! We're going to use the swing library, which will make a beautiful program, and we're going to actually make a GUI that wraps around our counter class. So let me show you the program. So we have our counter class, and now we have counter GUI.java, where I do everything. Okay, so we're going to make a counter that holds our state. It's going to be static. It's going to belong to this counter GUI class itself, not any object of it. We'll make a main function, and then we're going to say that C is a brand new counter. Okay, so now this C will be used in our program. Let me actually just go and run the program for you to show you how cool it's going to be. We'll say counter GUI.java counter GUI, and here we go. I can say increment to increment it, click the button, reset it back to 0, increment it some more. So that is what we're going to make together. Java is awesome. Okay, so I'm going to import some things. That's Java's version of include. And then I'm going to make GUI stuff. So this is all part of the library. A JFrame is part of this. If I go down, everything starts with J. A JFrame is essentially a window. Okay, and you can click on it and see what it has. But we're going to make a new one of those to hold our window, and it can hold other things inside of it. This is essentially a window. Okay. Dun dun dun. And apparently, if you don't use this line, the little X when you click it won't actually close the program, which makes no sense at all. But we're going to make sure that when we click the close button, it actually closes. And so then we're going to start putting stuff inside our window. And the thing that you put stuff inside of is called a panel. So a JPanel is a very generic kind, and it holds just stuff, components, we say. Okay, so how do I want to talk about this? Let's see. So far, if I just comment out the rest of this stuff, the stuff that we're putting inside, dun dun dun. We eventually have to add the panel to the window and do some extra stuff. But let's see what we get so far with just that. Just those lines that we talked about. We have a window that doesn't actually have anything. I think it might be very small right here. There it is. Counter GUI. There's nothing there. It has a window title. That came from right here when we use the constructor of JFrames. It says counter GUI. And then we added our panel. That's supposed to hold stuff. Right now it holds nothing. To the frame, to the window. And then .pack means change the width and the height of the window to be perfectly the size of the contents. And because there is nothing inside of the window, it was very small to begin with, but I can resize it, of course. And we made sure that it's visible. Bam. And then if I click the close button, the program stops. So that's so far what we have. And then let's start adding stuff. The first thing that we'll add is a text field. We'll say it's three characters wide. It's not editable because we're going to add our own stuff. And the current initial text is going to be what our count is from our counter. So it's initially going to be 0. We're going to make the font size huge. Okay, so that's a text field. If we go and add that to our panel, this is going to be a bit odd. We can add that to our panel, and now it just has the text field. And it'll hold 0. Oops, I need to actually recompile that. Hey, and so we have a text field. It's 3 characters wide, and it holds 0 at the moment. So I can make it bigger, and there it is. That's our GUI so far. And making this font size bigger, it's just a thing that you read the documentation to do. It's right here. I made a little helper function. You just gotta say set font, get the font, and then like make it slightly bigger with a new size that you give. Not very interesting. But everything, every button, every text field, it inherits from a class called JComponent, if that is helpful for you. Okay, let's add buttons now. All right, so the first button is the increment button, and then the next button is the reset button. So we'll add those to the panel. I'll just go from left to right. And so we make a button. The text of the button is increment and reset. Then we have to say what we want to happen. We'll also make the font size big. We have to say what we want to happen when it's clicked, okay? Right now, if ink is clicked, nothing happens unless we add these 2 lines. So I've made a special class that has a function inside of it that gets run every time ink is clicked. Okay, so it's called an action listener. So my ink click handler, it's a special class that extends, or it implements, the action listener interface, we say. So this is the function that gets run whenever the button gets clicked. This is what's required to implement the action listener interface. And so whenever this button is clicked, we have to increment, because that's the ink button, increment the counter. So we have to give the counter in the constructor and everything, and then we can reset the text field to be the new count. Okay, hopefully this is all making sense to you. This is just fancy stuff that needs to happen whenever the button gets clicked. And action listener is not a class, actually. So this is not extends, it's what's known as implements. So Java has both extends and implements. Implements is for something called interfaces, which is like a lightweight version of a class. It's like an abstract class. It just says, you need to implement these methods, please. In that case, you will be an action listener. So in order to implement this interface, all you have to provide is this action performed method. So if you go and look this up, this is the one thing that you need in order to be part of the action listener interface, and it knows what to do when an action happens now. And the action that happens on buttons is clicking. Okay, so we implement our handler and we install it to the button, and now every time the click happens, it's going to run that function, which is super nice. That will go and recompile. And that'll go and increment the counter object, the C object that we pass along, the counter C, to change its count, and then reset the text field's contents to be what the new count is. Okay, so that's what the increment button, its click operation does. Okay, and then we need reset. Reset, you can actually do this a bit faster. These handlers, you can just make an anonymous class, in fact. So you can say, add action listener. Oh, here's a brand new class with that one method implemented. Here you go. What it does is it needs to reset C, so you don't have to pass it along. It just knows about the C that exists outside. It knows about TF, the text field. So it essentially does all the same things in much less space. Otherwise, you got to make like constructors, a whole nother class. No, this is a bit faster. So I encourage you to mess around with this stuff. Obviously, I don't have nearly enough time to teach you the Java that I would like to teach you. So that's what happens when that button gets clicked. It will reset the counter and change the text field to be the new count, which is always going to be 0 in this case. So boop, boop, reset. I just keep saying reset. I mean, it's still going to be 0. And so now we have a counter GUI. It's beautiful. We just adjust the window to the size of the stuff inside of it. We say it's visible. That's our main function. And yeah, we had a special handler if we needed it, but really you can do all that inline with an anonymous class, we say. So I really encourage you to look at this stuff. It's really cool. And that is all the Java I have time to teach you at the moment. So hopefully you want to learn more now. Okay, so GUI is a graphical user interface. We just have a lot of stuff. There's a bunch of components pre-implemented for you in the Java standard library. And we can build them all up to make a GUI application, which is something we have not done. Like in C++, I mean, I gave you that one fade example, but that was never something I would teach you because it requires an outside library, and it's very fancy. So this is quite easy to make a GUI in Java. Okay, time for Python. Are you ready? So again, go to this website if you want to look at more Python stuff, like a quick little tutorial for Python. And then there's a very classic XKCD comic that goes along with this. But let's talk about Python now. Java, it's a bit terse. Like you gotta spell everything out. Like method names get really long in Java for no good reason. Like if we go back to this documentation, like abstract formatter factory. Yeah, that makes a whole lot of sense. Layout focused traversal policy. Of course. Yes, that's it. That's exactly what I would name it too. All right. Python, there's not a whole lot. So hello world in Python is going to be one-liner. It's going to be a one-line piece of code. All we have to do is print something. There is no main function necessary. In Python, you can just start writing code, which is super nice. All right, let's do this. So I'm going to make a file called hello.py. Okay, that is the .py is the extension for Python programs. And all I have to do is write one line. I can say print, then some parentheses, and then hello world. That is all I have to do. And a comment, it starts with a number sign. That's a single line comment in Python. We say this prints to the screen. Something like that. Okay, it's a one-line program. And if I go and I say Python 3, because Python 3 is the cool version that we use these days, Python 2 is outdated. You say Python 3, then the name of the program, hello.py, and it just goes and runs that. It is hello world. Okay, that's super nice. So let's talk about why that does what it did. The very first thing that I want to talk about is that Python is an interpreted language. There is no compilation process. And therefore there is no machine code that gets generated. It's just the Python system, the Python language runtime. It just reads the file itself, line by line, and goes like, okay, this person called print, so I'm about to print to the screen. I'm going to go and execute whatever this is to get it to a string, and then I'm going to print it out. So it interprets the program. It doesn't compile it. There is no CPU instruction going on. It's as if you're speaking Python to the Python runtime, and it is going and speaking to your computer for you. Okay, it's a different thing than a compiled language. This makes it a lot slower. Java is kind of partially compiled, but C++ is fully compiled. Python is ridiculously slower than both of these, either one. Okay, then let's get into some more fun stuff about Python. Let us talk about, let me just make sure this is still recording, yes. Let's go into Python itself. So, actually I can keep this open. Python has what's known as a REPL. It stands for, let's do it like this. This is a multi-line comment with 3 quotes. Python has a REPL, which stands for read, eval, print, loop. If you just run Python by itself, it'll plop you into the REPL. Okay, so if I say Python 3, here I am in the REPL, I can write code and it will run it for me. I can say 42. Oh, the answer is 42. I can say print hello, and it prints it out to me. You don't actually need, single quotes and double quotes are the same thing to Python. There is no character type, at least like this. It doesn't matter if you use single quotes or double quotes, so I could just go back and change these to double quotes if I wanted to. Change them from double quotes to single quotes. Between single quotes and double quotes and single quotes, no difference at all. Super duper fun, and they'll just run. If I go back and I rerun them, do the same exact thing. There's no difference. Back to the REPL. Finally, there's a to the power of operation. 2 to the 8 in Python. You can get the length of a string with len. Just a lot of fun stuff that I don't have plenty of time to talk about, unfortunately. Please come to office hours where I do have plenty of time to answer your questions, though. I guess we're going to get to this one in a little bit. This one I don't have enough time to talk about today, I don't think. But the libraries are super nice in Python. Maybe I'll talk about one of them. And I'm going to give you an example of the counter class again to talk about methods. And before we get there, let's talk about these things. So Python is what's known as dynamically typed. So if I want a variable called x, I just say x equals 42. There's no type anywhere. I just say, you don't have to declare it. It can have any type. So I can say, okay, x is 42, print x. X is hi mom, print x. It doesn't matter. It doesn't care. It knows what the types of these things are. But those don't do anything. Vim is giving me weird errors for no good reason, just because I'm not writing nice Python. Like, I'm writing it outside of anything. So it thinks it's weird, but it's totally fine. This is how most people write their Python scripts. All right, so yeah, x can be both 42 and hi mom. There's no types necessary. So that's fun. And if you want to make a function in that case, there is no return type. You just say def. So I can say def, this defines a function. Like print x plus 1. It takes an x, which again has no type. Hopefully it's a number. And I can print x plus 1. Okay? That's how it works. I can call it print x plus 1 of 42. Boop. And it prints 43 for me. Isn't that nice? So that's Python in a nutshell. Dynamic typing, no return types. White space matters. So in order to define a function, I had to tab over. And if you change those tabs, it suddenly doesn't work. Okay, you must tab over to write the body of this function. There are no braces, just indentation, just white space. That's what Python uses to determine whether or not you're inside the if statements body, whether or not you're inside the definition of the functions body. Okay? Lists instead of arrays, those are the normal things that people use. So this is a list. L equals 1, 2, 3, that's the syntax. You can get the length of that list with len again, and you can iterate through it. You can say for x in L, print x, I don't know, print x times 42, why not? Hey, so there we go. Got for loops with colons, things like that. It's just all works. Instead of else if, you have to say elif, okay? There is no else if. In the language, you say elif instead, okay? And then if statements are, of course, also indented. Cool things like that. Now, let's talk about methods by creating a counter class again. So methods, they secretly have to declare a this parameter. So let's start making a counter class now. Counter.py. So say class counter, and what do you know? A colon and an indentation. Okay? So that's how we start the counter class. So again, indentation is key. And that's just how we do things in Python. And then, okay, this counter needs to have data associated with it. So you don't actually define that data up in here. To give member variables, those need to be defined in the constructor itself. Okay, that's what we want to do. And constructors use the method name is called underscore init underscore. That's instead of the name of the class. And they take all the arguments, but they take one extra argument. Every method, including the constructor, including underscore init underscore, it takes self as the first parameter. And that is a reference or a pointer, however you want to think about it. It is the object itself. It's the this from C++. So if I want a counter and I want a C inside of it, like an X inside of it or something, a count maybe, I can say def underscore init. Actually, this might do it for me. Why not? No, it won't. Def underscore init underscore. And then self is the one parameter. Okay, so I can say self dot x equals 0. This defines the member variable. Okay, that's how we do it. So that's what we want, and now we can have other stuff. We can say def inc always takes self as an argument, even though you won't use it. Okay, I promise this is going to look a little bit weird, but we'll just get through it. We say self dot x plus equals 1. There's no plus plus in Python. Okay, that's inc. Then we can have get x, self again, of course, return self.x. You see me trying to put semicolons. I think that's all we really need to worry about. I can do reset, of course, but this is good enough. So to make a counter object, there is no new in Python. You just call the constructor to create an object. So I say counter, like that. I call its method, its constructor. So C is a counter. It's equivalent to that from Java, or the equivalent in C++. And then I can say C dot inc. I can say C dot get x and print it out after I inc it a couple times. Oops. And notice that there's no self anywhere. Python includes it for you, but you have to explicitly declare it so that it knows which are the member functions and which are the static methods of the class. You'll have to read a bit more about that or ask me about it in office hours for a better explanation. But yeah, that's the idea. Those are counters. And now we have 3 printed out to us. It's so beautiful. Okay, so that is Python in a nutshell. Indentation is key. There is no new. You have to explicitly declare self as one of the parameters. Actually, I typed this over here. You have to declare that secret this parameter. It's called self, but it's automatically given to you. How do I want to say this? Method calls automatically pass along yourself. So you don't have to give that secret first argument. It just is done for you. Constructor is called 2 underscores init 2 underscores, and yeah, that's about it that I wanted to show you there. That's Python. A really cool library is called the Turtle library, and let me use the last couple minutes to show you some cool stuff about that. So let's pretend that this is what the library is all about. Pretend that there is a turtle, and somehow, this is my best turtle drawing, his tail got dipped in ink. I'm not naming names, but this happened. And so this library allows you to move this turtle around the screen and draw things. He will respond to your every command. Okay? That is a really nice library that I like to use in my CSCI 1 class to teach students programming. So that is Turtle. Let me just show you a few things that you can make in Turtle, and then you can explore them on your own if you'd like. So here's one thing that you can make. Here's the library documentation. So you can make really cool things with your turtle. The turtle is an arrow in this case, but you can make the turtle look like a turtle too. So you can just move him around, like go forward, go left, and you can draw stuff. It's really, really cool. And you can change the colors and all that. So let me show you 2 examples of Turtle, and then I'll let you go. So the first one is the Mandelbrot Fractal, if you are interested in that. This is how you use the Turtle library, again, import it, to do cool stuff. So this is nice and commented, so hopefully it makes sense. Who knows what my errors are, but that's okay. So let me show you this, and hopefully you can walk through it yourself, using the Wikipedia page maybe. But this is going to draw the Mandelbrot fractal using turtles. So Python 3, Mandelbrot. So that's one cool example. And so you got a turtle, he's drawing this fractal, which is very complicated, but he's just working his way from left to right. And you can draw fancier things like in lines, but this is like 1 pixel at a time for this one. So that is the cool Mandelbrot fractal plus a turtle. That's one example. And then my other one is, you know that Joy Division album that all the hipsters have t-shirts of? Well, that is something we can draw with turtles as well. So actually, the data on that album cover is a signal coming from a celestial object, and we can just reuse that data and draw with turtles that album cover / popular t-shirt. So this is a bit more complicated, but feel free to walk through it yourself. I'd be happy to go through it with you in office hours or on Piazza. But here is the turtle drawing the Joy Division album cover. And you can see him working away. Very, very fun. And so at the end of this, you can be the ultimate hipster and have this album cover not only in cool, like, pixelated almost form, but there will also be a turtle at the very right side. So that is an improvement in my opinion. All right, so that is Python, that is Java, that is all the time that I have to teach you languages other than C++. the final week of classes will just be review. Hopefully you got something out of this. It's not too bad. All these other languages, they look kind of the same. You can do similar things. It's just a slightly different syntax, and you will get used to it if you try it. That is all that I have for you. If you want to do any exercises, the best ones are to convert some of your labs to use Java and or Python. That's a great way to learn these languages. Like look up the little, go through the tutorial, and then change over one of your labs. Super, super useful, I would say. So that is Beyond C++. That is the one lecture for this week, and that is all I have for you. So have a good Thanksgiving, and I will see you in the next lecture.